Hello. It's been a while. Thank you everyone for joining. Today we'll speak about very technical and very hands-on topic. And our today's speaker is Mikita Zadarozhny. Hello, Mikita.
Hello, everyone.
He is very strong Java engineer with strong cloud background. And before giving him a word, let me just in 2 words talk about our rules for today's session. In general, feel free to ask your questions using YouTube, using their community, chat, comments, whatever. We'll answer them during the session. I will just talk your questions to Mikita and he'll answer during either special sections as either during his talk. That's mostly it. Mikita, floor is yours.
Yes, hello everyone one more time. My name is Mikita, and today I would like to discuss with you AWS Lambda. But first, let me introduce myself. So, I've been software engineer for 5 years and a half, joined EPAM 2024, and currently I'm focusing on microservices, distributed systems, and cloud-native applications. And so, about my credibility, I'm two times AWS certified. Okay, so that's pretty it, and let's begin. So, but before we start talking about AWS Lambda, my suggestion is to take a look at the basis. And namely, I would like to discuss with you serverless computing in AWS. And the first question to the audience: do you know what serverless computing is? Let's wait for like 30 seconds. Maybe someone will be able to answer this question. Okay, no worries. Let's proceed. So actually, servers indeed exist under the hood, but the only difference between like serverful and serverless application is that you're not responsible for managing the underlying infrastructure. It is your cloud provider who does it for you. Okay, let's move forward. And so before moving forward, I would like to take a look at the short list of AWS services that follow this particular paradigm. Namely, we will take a look at the AWS Lambda, which is our main focus for today. Then we will take a look at AWS DynamoDB a little bit. So it will be integrated with our AWS Lambda during our main part, namely workshop part. We will ignore ECS and EKS for Git, but it's still quite important to know that there's such a mechanism like serverlessness for these two services, and we will configure SQS and SNS to work with our AWS Lambda, like little agenda for our presentation today. Let's move forward. And let me first introduce you like the main service of today, AWS Lambda. What is the purpose of this thing? The idea of this service is quite simple. Actually, it allows engineers to focus on writing the code solely, mostly, yes, without need to take care of the underlying infrastructure. But it is the only idea. And you see, even in serverless manner, you always need to consider the right infrastructure in case you do not want to create some subtle bugs that are difficult to find. Okay, so what else we have? And also, AWS Lambda is quite a convenient way to enable event-driven development approach, so to your application. Let's move forward. And what are the main components for AWS Lambda? Let's take a look at all of them. Actually, it is the Lambda function. I will introduce you all these terms like in a short terms, yes, like 2 or 3 words for each of them, but more sophisticated explanation to every single term. We will meet a little bit later throughout our presentation for today. And what is Lambda function? Lambda function, it is the code that you write and that does some business logic for you. Okay, execution environment. Even so, as I mentioned before, AWS Lambda is a serverless. Yes, we have already discussed that serverless doesn't mean that there are no servers under the hood. It's just not you who manages these services, okay? And execution environment, it's just very small virtual machine where your Lambda function runs. What is the AWS layer? AWS layer, something like dependency which you might attach to your Lambda function. Yes, we will discuss it in more details a little bit later. Synchronous and asynchronous invocation is pretty straightforward and self-explanatory. We will skip this part and we will take more close look at this later. And event-driven trigger, event source mapping, we will also discuss this a little bit later, because this terms quite complex to cover in 3 to 4 words. Okay, let's begin with our main part, Lambda function. As we discussed it before, Lambda function, it is something that you write, and it is something that does some business logic. Pretty straightforward. And please never mix it up with the AWS Lambda. AWS Lambda and Lambda functions are different concepts. AWS Lambda, it is the service in AWS that manages all the Lambda functions that you write. It's very important to distinguish these two terminology. What properties exist for this particular entity, namely Lambda function? Actually, every single Lambda function, as it was mentioned before, runs in a dedicated execution environment. Yeah, and this Lambda function is triggerable. And what does it mean to be triggerable? Actually, AWS Lambda follows paradigm like pay as you go. What does it mean? It means the following stuff: that when your Lambda function is not used, you do not pay for this. For example, consider the following situation: you have something like 1 million invocation for your Lambda function per month, and all of them happens, for example, on 1st July, and you will only be billed for the 1st July. You won't be billed for other days, because during the other days there were no invocation for your AWS Lambda function. Okay? In case you have any questions, feel free to ask them. I will try to clarify them all. Okay, good. So, and the idea sounds quite good. So actually, you just write the code and you do not take care of the underlying infrastructure. It's like a paradise. But unfortunately, every single implementation of a good idea has some shortages and disadvantages. And the Lambda function, AWS Lambda, is not exclusion. And let's take a look at the limitation that comes with this thing. The first one is, and the most important limitation, it is the execution time. Namely, your Lambda function cannot run more than 15 minutes. But recently, it stopped being true, and we will discuss it a little bit later. Currently, it is possible to run your Lambda function for like 1 year, but we will cover it a little bit later. It was like a new feature. And allocatable memory. So you're limited to 10,000 megabytes. Yeah, you won't be able to allocate more. So execution time and allocatable memory are hard limits that are impossible to surpass, unfortunately. But there are some limitations that are quite easy to surpass. For example, concurrent executions. What does it mean? Your Lambda function might be executed in parallel. Yeah, there might be many customers that want to invoke your Lambda function. Yes, and they invoke it indeed. And your AWS Lambda creates some number of execution environments. Yeah, per each we have a Lambda function, and they are running within them. And so the maximum number of concurrent executions, of concurrently running execution environments that might be within your region in AWS account is 1,000. But it is the soft limit. And actually, it is possible to communicate with AWS support team, and these guys will increase these limit. For example, from my experience, it took like up to 10 days, if I'm not mistaken, yes, to create a mail for them, not a mail, like just a message. It happened within the AWS console support team chat. Okay, you just explain why you need to surpass this limit, and after this, the team will communicate with you, and they will increase the limit in case your arguments are strong enough. Okay. And they are not able to change your mind, of course. And let's move forward. It is not the only limitations that we have for Lambda function, unfortunately. So, second page of important limitations. It is the accumulated size of all the environment variables that you have for your Lambda function. You see, I've seen a lot of applications that configure that okay, that might be configured only using the environment variables. And this is the huge problem for Lambda functions, because for Lambda functions, accumulated size of all the environment variables might not exceed 4 kilobytes. It's like 4,000 characters, depends on the encoding. And the biggest problem here is that if you store, for example, URLs or, for example, credentials, which is very bad practice, yes, in environment variables, you might easily exceed 4 kilobytes, and you won't be able to configure every single thing. And thereof, Lambda AWS team recommends you to proceed with other mechanisms for configurations. So, for example, you will be able to store like secrets within the AWS Secrets Manager, yes, and you will be able to store like URLs or whatever, yes, in parameter store. This services works with AWS Lambda flawlessly, and it means that you won't see any issues integrating this stuff with the Lambda function. Okay, and also dependency layers. We will discuss this thing a little bit later. I'm talking about dependency layers, but keep in mind that there you might assign only 5 of them. And of course, I will remind you about this a little bit later. Okay, good. Now let's take a look at the good use cases for this thing. Actually, every single job that does not require a lot of resources, namely either RAM, random access memory, or processor time, is a good thing for Lambda function. For example, if you want to create a user in your Active Directory, or you would like to create some row in your database, yes, a database table, or you would like to perform a secret rotation. For example, AWS Secrets Manager is integrated with AWS Lambda function to perform secrets rotation, which is extremely convenient in case you want to do so. Or sometimes you might use Lambda function to integrate with third parties. For example, you might send webhooks, but actually it's just one of the use cases, yes, with integration with third parties. And for webhooks, there are other better alternatives. Okay, for example, even pass API destination. Okay, let's move forward. And we should keep in mind that AWS Lambda function is not a silver bullet. It is impossible to perform every single task that can come to your mind, yeah, using AWS Lambda. And namely, there are some set of tasks that cannot be performed, cannot be easily and inconvenient way be implemented by using AWS Lambda functions. Namely, for example, every single job that requires a lot of random access memory or processor time Lambda function won't be a good fit for this thing, for these cases. For example, if you would like to render, I believe that some of you saw the film like Interstellar, and there was a scene with a black hole, yeah? And the biggest issue with this thing that they spent, if I'm not mistaken, like 1 year for rendering this scientifically accurate black hole. And Lambda function, you won't be able, in order to perform this task using AWS Lambdas, you will have to divide this large job into subparts, and you will have to orchestrate multiple Lambda functions to achieve this goal, which is not quite. It is still possible. It is still possible if you prepare well for this goal, but it's not always convenient. And there are different mechanisms that fit these situations much better. For example, AWS Batch. So, for example, case like machine learning or memory-heavy algorithms such as dynamic programming. If you're familiar with this, you know what I'm talking about. You won't be able to implement them efficiently, so using Lambda functions for a large data set. And this is the huge disadvantage. Okay, so and now I think that we covered the basic, and I would like to proceed with what? So with some hands-on. I've prepared some code for you, and we will get through all of them through this code, yeah. And we will deploy these Lambda functions. This code will be shared with you after the presentation, and it means that you will be able to perform every single operation that I do right now with yourself. Okay, let me enter the presentation mode. Okay, good. So it is the first version of our Lambda function, namely create order event handler. So every single Lambda function that you want to implement should implement interface request handler, but it's not always like this. So for example, if your Lambda function, if you would like to supply your Lambda function with some custom types, in my case, it is create order event as an input and order created event as an output. Yes, you will have to use request handler interface. Yes, your Lambda, your class that implements Lambda function should implement this interface. Yeah, and in case you want to proceed with some simple types, for example, like list, map, string, integer, stuff like this, you might need this interface. Yeah, it's going to be quite simple. And actually, we need this thing only for like convenient mapping. Yeah, because the environment will does it for you. Okay, and let's take a quick look at the create order event. Yeah, this detail. It's quite simple. So let me first introduce you to the domain a little bit. So we will have the following application. We will have a short Lambda function. Yes, and this Lambda function will communicate with the DynamoDB table. So we will be able to create some dummy orders using our Lambda function, which will connect to DynamoDB and store your orders there. Quite simple. Let me show it on the presentation. It's going to be just a second. It's going to be quite easy to understand. Yeah, it's like this. We have just simple Lambda service manages Lambda functions, and every single instance of Lambda functions that we have will store something within the DynamoDB table. Okay, let's move forward. Let's move to our code. And yeah, I believe that you were able to understand what we're going to do. And now let's move forward. So our Lambda function has one downstream dependency, namely DynamoDB, and we need a way to connect with the DynamoDB. And for this purpose, we will use like DynamoDB client. Pretty straightforward. So, and the thing is this: in order to create our DynamoDB client, we have to specify the region that we're going to use to connect to our DynamoDB table. And I pass this particular argument through environment variables to our Lambda function, like here and here. Okay, so actually we just use system get invocation in order to get the region where our Lambda function is deployed, because I have an intention to store both AWS Lambda function and DynamoDB table within the same region. Okay, and then through the same environment variables, I would like to store the DynamoDB table, yes, and receive this information from environment variable using our Lambda function, where we will be storing our orders. So keep in mind that we have two environment variables. We will configure them a little bit later when we're going to get back to our AWS console. Okay, fine. So you need to understand that every single time when your Lambda function is invoked, yeah, you create a new instance of this particular object. It means that the constructor is going to be invoked every single time you invoke your Lambda function. And those guys that have already worked with the Lambda functions might know one optimization that is even recommended by AWS team, but we will discuss it a little bit later. Yeah, let's keep it as it is. We will take a look at that version a little bit later. So then our create order event handler, implements one method, namely handle request. Yeah, what does it do? It receives two arguments. Actually, the first one, which contains the information about the event that triggered our Lambda function, and the context. Context is more like meta stuff. We're able to receive, for example, get logger, or we are able to receive logger from the context and store some data within CloudWatch, for example. And what else? And we are expected to return order create event from this particular method. Okay, pretty straightforward. This method is pretty straightforward. Let's dig in. We have two methods within our Lambda function, yes, for better like responsibility segregation. So after we receive this particular event, we go to put item into DynamoDB method. Here we do pretty simple stuff. We just create the put item DynamoDB put item request that is going to be executed, that is going to be leveraged by DynamoDB client in order to deliver the information about the order that we have delivered to our AWS Lambda function to DynamoDB. So we just receive the information, we parse the information, we create put item request, and we send this request through the DynamoDB client. The logic is pretty straightforward, and of course, everything is followed by logging. Okay, we will able to see everything within the logs. So I believe that in case you have any questions related to this particular Lambda function, let me know, and I will answer them. But if you do not have anything, let's proceed. I will give you like 15 seconds. Okay, looks like no questions. Let's move forward. The thing is this, we have the code and we need to build this, okay? And you see, so in order to build this, usually for something simple, I use 3 main goals, actually, the clean, package, and shade. Okay, if you're not familiar with the shade, this one just includes all the dependencies within the target jar. For this particular example, we have like AWS SDK dependencies, and in order not to add them like dependency layers, I will follow the simplest possible way. I will just shade everything. Okay, so let's execute this. And in order to make everything as clear as possible, I will remove the target directory. Okay, so it is removed. You see, nothing is here. And let's build everything. Okay, it might take some time, but not a long while. Okay. Okay. So here we are. And we are mostly interested in this particular shaded jar. So we have compiled our code. Yes, currently we will focus only on this particular implementation, but there are some more of them, and we will discuss them through our presentation. Okay, throughout our workshop. Let's move to AWS. Okay, just 1 second. Let's move to AWS console. Namely, we're going to start working with AWS Lambda. Okay, let's open the service. Okay, this one. And the most important thing, it is to create our first Lambda function. Okay, let me create one. Let it be like workshop Lambda function. Okay, and let's specify the environment. We're mostly interested in Java 21. Okay, after this one, do you remember I was telling you that 15 minutes is not the hard limit any longer? Yeah, because recently a new feature, durable execution, was added, and you will be able to specify the execution timeout till a lot of days, if I'm not mistaken. Yeah, but we're not interested in this functionality right now. We're interested in like default one. Okay, so we will disable durable execution so far, and we will proceed with the like traditional way. Okay, so we do not need to specify anything else. Yes, the default values are fine for our simple case, and let's create the function. Okay, so after we created the function, of course, we need to upload this our code that we have just compiled there. Okay. Okay, so our Lambda was created. Now let's upload the code. There are multiple ways to upload the code. Actually, namely not multiple, but only 2, using like zip or jar, or you are also able to upload your Lambda function code to to Amazon S3, and you will be able to fetch this information from there and put it into your Lambda function. But let's proceed with the simplest way. We will just put a recently built jar here, just drag and drop. Okay, pretty straightforward. Let's do this. Okay, let's wait for a little. It might take some while. Yeah,
Mikita, I was like forced, was muted, was hidden. So we have a couple of questions. First is regarding the code, where is the annotation to start the LBDF?
LBDF? What are you talking about? I didn't get the question.
Me neither. Maybe just starting of Lambda.
LBDF. What is the LBDF?
Yeah, Ricardo, could you please
Could
Lambda
you please show me
function?
the Could you please show me the question? Could you please show me the question?
Just Lambda function. Annotation for starting of Lambda function.
Actually, so you do not need any annotation to start your Lambda function. Actually, the only thing I will show you a little bit later how to specify the entry point for your Lambda function. Yeah, I understood the question. Most probably the viewer is interested in the way how we understand which method is the entry point. Yeah. And just 1 second, it was exactly the next thing that I wanted to share with you. None of these annotations actually are used for this purpose. Yes, none of them. And in order to specify the entry point, we need to go to our Lambda function, yes, within the AWS console. We need to click on Edit button. And here, we need to specify the reference to the method. You see, by default, it is example, hello handle request, but we do not have such a thing here. And we need to copy the reference to this handle request method and put it here. Okay, you see, now our Lambda function in AWS console will be able to understand which method is the entry point for us for the execution. So did I answer the question?
I hope so.
Okay.
Yep. One more
Other
question.
questions?
Yep.
Sure.
How does Lambda authorize to the database?
Yeah, that's a good question, and we will take a look at this right now. After we create the DynamoDB table, I wanted to show you the default way without configuring any permissions. We will see that our Lambda function won't be able to store anything within the DynamoDB, and then I will configure the permissions, and you will be able to see this. Yes, it is we have this thing little bit afterwards. Okay, so let's move forward. We have just created our Lambda function. We have specified the handler which we want to execute, which is going to be our entry point. And then we are interested in our downstream dependencies. Namely, let's create the DynamoDB table. Let's open DynamoDB. Okay. DynamoDB service. Let's go to the tables. Let's create a table and let's call it like workshop orders. Okay, since our demand is some simple delivery service, yes, let's follow this naming. Okay, partition key. Let's take a look at what we expect. We expect the ID, yeah, ID. Okay, and ID should be a type of S. Its type should be S. Okay, it means string. Okay, ID partition key is ID, and sort key creation timestamp, and the type of this is number. Okay, it's possible to understand from the factory method, from S, which means from string, from N, which means from number. Okay, let's specify this thing. So yeah, that's enough. That must be enough. I believe that I haven't forgotten anything to configure, because in this case I will have to recreate everything, and it's not a good thing to do. Okay, we've just created a table. Let's wait for a little, yeah, and let's now configure our Lambda function in order to communicate with the DynamoDB table that we have just created. Okay, just 1 second. For this thing, yeah, we will need just to copy the name of our table. Let's get back to our Lambda function. Let's go to configuration tab and open environment variables. Okay, do you remember I was talking that we have 2 environment variables? Let's add all of them. The first one, it is the this is the one responsible for DynamoDB table name, okay? And the second one is AWS region. But this thing is set up by default. If you try to add it like this, US East 1, for example, yeah, you will end up in having an exception, okay? Error that you're not able to specify the reserved key. You won't be able to specify the environment variable for a reserved key, like AWS solution. Okay, in this case, we won't configure this thing. We will just stick to the first environment variable, and nothing is important else. Okay, it means that after we save this thing, our Lambda function will know to which DynamoDB table it would like to connect to, but it's still not enough. If, for example, we want to execute our Lambda functions right now, yes, let's try, and we will end up in having an exception. Okay, good. Let's create some test JSON. Okay, let's create a new one. Let's call it create order event. And it should consist of two fields. Actually, item name, which might be, for example, Korean, And for example, and the second field is delivery address. And let it be Tiflis, Georgia. Okay, good. So if we send this event right now, let's save it. Just 1 second. What did I do? Oh, okay, I did a mistake. Very stupid mistake. Okay. So let's save this. Okay, it was saved. Now let's execute, and you will see that this we failed with an error that we did not have access to our DynamDB table. Okay, let's just wait. Yes, and you see that yes, this particular role workshop Lambda function is not authorized to perform DynamDB put item. Okay, and this is the thing that we have to fix. Okay, so how to fix this thing? We should go to the configuration and we should find the role which is assigned to our Lambda function. Actually, our Lambda function performs all its actions behalf some role. For example, our Lambda function does not have like every single permission that might exist in AWS. It has some subset that is configured by you. Okay, we go to role name. Actually, you just click on this thing, and IAM service will be open, yeah, where this particular definition of this role will be present. Okay, we have only one policy here, which does not contain anything related to DynamoDB, and it means that we need to create one, introduce one. Okay, let's create a line policy. Let's choose JSON editor, and we need to perform the following action. Actually, we're interested in DynamoDB put item API call. Okay, do you remember exactly the one that we failed with? Okay, you see DynamoDB. Okay, where is this? Put item DynamoDB and on this resource. So we might either copy it from here, but let's go to our DynamoDB table. Let's copy the ARN from here. You see, it is the unique identifier of your DynamoDB table, and let's copy it to the resource itself. Okay, pretty straightforward. Okay, so that's it. And effect should be allowed, means that we do not forbid this particular invocation. And say let it be like put item to what? To workshop orders. Okay, this character is forbidden. Okay, let it be so. Good, nothing else. This should be enough. Let's save this and policy name, put item to workshop orders. Fine. Okay, so create policy. So our policy will be was created. Yeah, we have this thing here. We have like the API call and to which entity we have this API call like permitted. Now you will see that this permission is created. Yeah. Okay. Good. And now let's try to re-invoke our Lambda function. And we expect to see a new entity created within our DynamoDB. Yeah, you see, we have returned the order ID. Oh, I haven't shown you the output DTO. Just 1 second. It's quite simple. We just return the order ID, which we manually create. Yeah, input item into DynamoDB method, like just generating random UID. Of course, it's just a dummy code. Never do something like this in your production code. It's just a dummy for like to create easy to understand example. Okay, good. So some order was created. Now let's go to DynamoDB, and you will see that this particular entity was created. You see this identifier 95. Yeah. 95. Okay, good. Delivery address is Tiflis, Georgia, and the item name is Korean. Good, perfect. We have just created the simplest serverless application in AWS that might receive some orders and store this information in some DynamoDB table. Okay, let's get back to our presentation. Actually,
let me interrupt you for a second.
Sure.
We have a couple of questions. First,
Sure.
Is there any differences between Lambda runtimes for different languages? Java, instance, Go, JS, whatever.
Of course. So, and the thing is this, it depends. Maybe I didn't really understand the question, but of course there are some differences. You use different runtime environment. For example, for Java runtime, you use like GRE. For Golang, you use some Golang stuff like this. Or you're talking about some like optimizations, yeah. If we're talking about some particular optimizations for different languages, unfortunately, I'm not able to answer this question because I didn't investigate the way for like Python or Golang, but the general idea is still the same. And I believe that the biggest difference that might happen there is like some optimization, like for example with a static variable that we will take a look right now. Yes, for Java, I believe that every single language that does not support this feature won't have this optimization. Okay, and it is even optimization not at AWS Lambda function layer, but mostly at like Java level. Okay, did I answer your
I
question?
think second question from the same person will add some clarification in the previous
Sure.
question. So, is there any reason to use a language with historically slow bootstrap to write Lambda functions? I
Of
think
course.
it's about Java.
Yeah.
It's
Yeah,
very
yeah,
slow
yeah.
and cold start. Could you
Yeah,
comment
yeah,
this?
exactly. It's very good question. Of course, it makes sense to do so. So, for example, some of my projects usually, actually, it depends. You need to measure everything. And fortunately, if you open your like Lambda function, you will be able to find the information about how much time everything lasted. So, for example, you were built for this amount of time, and I don't remember the place, but sometimes, unfortunately, I don't remember the place, but probably in CloudWatch or another place, it's possible to see how much time it take your Lambda function and execution environment to initialize. Yeah, let's take a look. I believe that it's pretty easy to find. Mhm. Let's open CloudWatch. Okay. So here we are. Just one second. Let's take a look at the log management. Okay, none of them. Am I in correct region? No, not in correct region. Okay, workshop Lambda function. Let's take a look at the log streams that we have. Okay. So initialization happens. Okay, just one second. Yeah, you see. Yeah, so here is the time that lasted that we needed to execute our Lambda function, namely 255 milliseconds. And here we have the time which we used in order to bootstrap our Lambda function. And I mean like execution environment with all its dependencies. Okay, you see that for Java, for extremely simple application in Java, we needed like 4 seconds. You see, it's quite a lot, and of course, it depends. It depends if you know some language that is known to have quicker bootstrap time. Yes, it definitely makes sense. It definitely makes sense, and of course, you're built for this initialization time as well. Yeah.
Yeah, Mikita,
Summarizing,
but
that
am
makes
I
sense.
understanding correctly that if Lambda is initiated and if it's called rapidly, it will continue just to work without spending some time for
Yeah,
a
exactly.
reinitialization?
Exactly, and it is the thing that we will discuss a little bit later. We are in a hurry, and I will cover everything. Do you remember in the very beginning I said that we're going to cover execution environment a little bit later after we complete the Lambda function? And indeed, okay, let me like provide some spoiler. Indeed, you initialize execution environment one time, it lives for some time. It might live for more than 15 minutes, and during its life cycle, it's possible to execute a couple of Lambda functions within the same execution environment subsequently. Okay, we will take a look at this in the section which is related to execution environment. Okay, did I answer your question?
But maybe for some cases, if Lambda isn't called like all the time, you can use some different language. I believe with AI adoption, it's easy to just rewrite your Java or whatever language
Yes,
to
of course, of
some
course,
other.
of course. So it is always important to perform some like workbench and measure which language suits you better. Okay. So for example, if you're interested in like a little called Bootstrap, yeah, then of course you just write your code, write your Lambda function in multiple languages. You start all of them using Lambda function, yes, using different environments, and you look at the duration, okay? Duration which was required for your Bootstrap phase. Okay, did I answer your question now?
Yep, hope so.
Perfect. Okay, now we're going to discuss the environment variable part. Oh, sorry, execution environment part. Very important one. Okay, so what execution environment is? Execution environment, it is the minimal possible execution unit in terms of AWS Lambda. Okay, so actually it is the entity that we use to run our Lambda function within. Okay, so how it works. Usually you create a request to invoke your Lambda function. For example, by clicking a button as I did in test, or by integrating it with some other services. And when other services have some event stable propagate them to your Lambda function, and it will result into either creating a new execution environment in case there are some idle, some of them that are in idle state, or creating a new if all of them are busy. Okay, and it might be reused. We have already discussed this part. Okay, good. Let's move forward. Let's take a look at the structure of execution environment. It consists of like three main parts, like the function that you have just implemented. Yeah, it is execution environment which runs your function. But it's not only GRE in case of Java. It's not the only GRE. Yeah, but you might think about this as with Tomcat and war files. If you work with Tomcat, you know that you deploy Tomcat and you supply it with your servlets that are packaged within the war file. And you see, you just supply it with this war file and it executes a little bit later, okay, when there is a need. And actually, we have similar situations for Lambda function, but we might have only one function per one execution environment. I mean the code. And the last thing, very interesting one, extensions. For example, sometimes you might be interested in integrating your Lambda function with some third-party applications. For example, there is some new cutting-edge AI-oriented like observability tool, and it's not yet integrated with AWS by AWS team. Yeah, and you would like to integrate it yourself. So you just create an extension. Yeah, you specify it within your AWS Lambda definition of a function definition, and it will run it as a sidecar. Okay. For example, your Lambda function has access to TMP directory, yes, within this small virtual machine called as, also known as execution environment. It might store some logs or whatever there, yes, and then these like byproducts that were created by function, your Lambda function, might be read by your extension that you've created. So let's move forward. If you like to take a look at this, some visual for this, yeah, we have AWS Lambda, which is the service which communicates with Lambda function, execution runtime, and extensions that are deployed, that are located within the execution environment through some part of some standardized API. Runtime API, extension API, telemetry API. Actually, it means that every single stuff that you have on the right corner of this picture might be implemented by the developers. You're able to do whatever you want as long as it like comply with the as long as it is integrated with these API, which are used by AWS Lambda to communicate with your code. Okay, understood. Let's move forward. Lifecycle. Now it is the most interesting part that we have just discussed. Okay, so our execution environment, yes, which is like a small virtual machine, has 3 phases: init phase, invocation phase, and shutdown phase. And mostly we will be interested in the first 2. Namely, so init phase, very important thing. First, when you start your execution environment, you run all the extensions. And namely, consider the example that we've just discussed about some new cutting edge AI-based observability tool, yes, that you run as a sidecar for your Lambda function. Yeah, you run all the first you run all the extensions, and then you proceed with initialization of your runtime. So, for example, you run Jira, you run some analog of Tomcat. Yes, of course it's not Tomcat in Lambda functions, but it's just relatively similar analogy that you might use. Yes, if you're new to Lambda functions and how it works under the hood, it might help you to build the abstractions and connections within your head, how it works. Okay, and simplify your life. And the last one, it is the functionality. Okay, but you might say, okay, so you, Mikita, you've just said us that we create our Lambda function, we initialize the object, yes, that handles our invocations to Lambda function every single time we receive a request. Indeed, it is like this, but function init means that we run all the static code that is present within our function. Okay, understood? Let's move forward. And it means that we receive the space for optimization. What does it mean? So instead of writing like this, as I mentioned before, your constructor is invoked multiple times, yes, for every single Lambda invocation, but some spoiler, I know it's not documented yet by some reason, but when I was making some tests, yes, the thing is this, by some undocumented reason, as this thing started working differently. Create order event handler might sometimes avoid invoking the constructor. But previously, it was always invoking the constructor. But now it works a little bit different, and we need to be careful with this new introduction. Yeah, but let's stick to the traditional way, which was tested and which is working for 100% and even recommended by the AWS team. Namely, instead of writing something like this, you need to proceed with this. Actually, since static code is initialized every single time, just 1 second, at the beginning, at the bootstrap phase of your execution environment, yes, it means that you will create only one DynamoDB client, and it will drastically decrease the init time for your Lambda function. Okay, because you pre-create all the necessary object. You pre-create your downstream dependency, which is DynamoDB client. Yeah, during the init phase, it is created only once, and it means that the overhead for every single Lambda function invocation will be smaller. Okay, now let's move forward. And now, Vladimir, it is the thing that you were asking about. The thing is this: every single Lambda function or every single execution environment might be reused, and its lifetime is not limited to 15 minutes. It might live longer. The thing is this: even after execution environment was created, yeah, you invoke it for the first time, because the purpose of execution environment to be created might be like a request to invoke your Lambda function. Okay, but there are some other ways to do so. There's a thing called as provisioned capacity in AWS Lambda, which you might specify, but sometimes we understand that 4 seconds in order to initialize execution environment sometimes is too much. Yes, and the AWS Lambda team suggested, so for the cases when we really would like to avoid this situation, they suggest us to use reserved capacity. It means that it will hold some number of execution environments, yeah, forever. Yeah, not forever, until you say not to do so. Okay, fine. After we have created our execution environment, and executed a couple of requests that were sent to this execution environment. So for example, created, then you received the first invocation, okay, then you went to idle state for 10 seconds, you received the second one, then the third one, the fourth one, then you in idle state, for example, like a couple of minutes, and your AWS Lambda, yes, AWS Lambda service terminates this execution environment. So it won't use resources in waste. And of course, you are not built for this time when your execution environments are not used. You're built for init phase and you're built for invocation phase, but you're not built for for dry run. Okay, so when it works, when it does not perform any business logic. Okay, so pretty straightforward, I believe. In case you have any questions, feel free to ask them. I will try to clarify if it wasn't clear enough. And the amount of invocations is not limited, but keep in mind that sometimes generally it's not recommended to rely on this logic, because sometimes you might think, okay, if I know that execution environments might be reused, my first invocation might perform some pre-computation that I might use during the second invocation and third invocation. And this logic is error prone, which means that if you do like this, there is no guarantee that AWS Lambda will send this particular invocation, yes, to the previously used execution environment. Okay, it is the issue, and not issue, it is the thing that you should always keep in mind when you're trying to optimize somehow your Lambda function, yes, using this principle of multiple invocations. Okay, good. If you have any questions, feel free to ask them. And the last thing,
maybe like not question, but comment to the topic that we discussed before related to cold start. Guys in the comments mentioned snap start to help solve cold start at most of the ways. What do you think about this?
So actually, it's not covered within this presentation. It's very important, I think. If we talk about snap start, how it works. First, you create the snapshot, snap start snapshot. How does it work? You spend some time for initialization. You have initialized your execution environment. You went through the first phase, which is the bootstrap phase, init phase. Then you create a snapshot of this thing. You store it, and then instead of creating execution environment every single time from the init state, you just recover it from the snapshot and moves directly to the invocation phase. It is in a nutshell. But there are, of course, some different disadvantages, and unfortunately, they're not covered within this presentation. Okay? Did I answer your question, Vladimir?
It's not mine questions, but I hope that.
Of course, I understand. Unfortunately, I do not know the name of this person.
Yeah, we have some delay in presentation, so that's why I can't answer those guys satisfied with the answer or no. So let's continue. We'll have some feedback later.
Sure. Let's move forward. Now let's talk a little bit about AWS Lambda layers. Most probably, the most boring part, but we need to get through this. So what is the Lambda layer? It's just a zip file, that you upload to AWS Lambda that may contain some dependencies, like libraries, sometimes some data, or even custom runtimes. Sometimes I know that there was some guy that was asking about different runtimes, and in case some sophisticated optimization came to your mind, it's possible for you to implement your own runtime. You will be able to, so you will know everything about this, and you will be able to implement this and use it for your Lambda function. Okay, so AWS Lambda is quite flexible. You are able to do almost whatever you want, but you need to keep in mind the limitation that we have discussed in the very beginning of our presentation. Okay, fine, let's move forward. And what is the purpose of Lambda layers? Okay, quite straightforward. Code reusage, of course. If you have multiple Lambda functions, you might not always want to, so if you have multiple Lambda functions and all these Lambda functions have some common code, Why do you need to include this code into every single Lambda function? It is possible to move this common code to some dependency and to some library, like package this and upload to AWS Lambda, and then you will be able to assign this thing to your Lambda function as a layer. Let me show it to you. So, okay. Now we need to go to Lambda function, to our Lambda function, and layers are present here. Okay, so you just click on this, here. Okay, layers, and it's possible to add layer. Unfortunately, you're limited only to 5 layers. At least last time I checked, it was 5 layers, and you're able either to choose some AWS owned. There are a lot of extensions for Python. If you want to find something for Java, you will be able to find something only OpenTelemetry and Configure. Okay, provider, nothing else. And if you want to add some layer for your Lambda function, now for your Java Lambda function, you will have to upload your own layer. Okay. Also, it's out of scope. It's quite nothing, and in order to save our time, we will skip this. Okay, let's move forward. In case you have any questions, feel free to ask them. And the first thing is code reusage, yes, which is always a good thing to do, and deployment package size reduction. What does it mean? Imagine that you have extremely large Lambda functions. Okay, it's impossible to store a Lambda function whose size is more than 250 megabytes. And this size is accumulated with all the dependencies that you have. Yeah, actually, the hard limit for your Lambda function with all the dependencies is 250 megabytes. You won't be able to surpass this thing. And you see, it's just limitations, just nice to know. But if you have like relatively large Lambda function and you do not always want to spend additional time on uploading the whole code, for example, you've just changed one line, you didn't change dependencies of this. Yeah, you are able to upload all the dependencies beforehand and then only re-upload the part that was changed, which is very useful. Okay, but currently we're living in the world with a high-speed internet, which means that usually it's never a problem. But of course for AWS networking, you might be built sometimes for this thing. Okay, let's move forward. So fortunately, we have finished with the most boring part, dependency layers. Let's move to something more interesting: synchronous invocation. Okay, actually, every single time we invoked our Lambda function was synchronous. And how it is possible to see this thing? Actually, we were executing this using the test tab, but I will provide you more details about synchronous and asynchronous invocation a little bit later on later slides. Okay, when we're talking about test, you might be able to specify either the synchronous invocation or asynchronous invocation. And now let's take a look at all of them. The first thing, what does it mean to invoke Lambda function synchronously? It means that first, you send request to AWS Lambda, which is the service responsible for managing your Lambda functions. You receive the request, AWS Lambda received the request, not you. It invokes the Lambda function either by creating the execution environment or by reusing the one that was in idle state. Then it waits for a result to be delivered backward from your Lambda function, and it delivers back to the Lambda function invoker. Pretty straightforward, default synchronous invocation model. Okay, nothing special. And how to invoke your Lambda function in a synchronous manner? It's possible to do like AWS Lambda console, CLI, AWS SDK, invoke API, and function URL HTTPS. We won't cover all of them. We will just cover the first two. And how to invoke it using Lambda console. It's possible to invoke your Lambda console, invoke your Lambda function using console and synchronous invocation using this command. You see, by default, when you invoke your Lambda function, you invoke it synchronously. And a little bit later, I will show you how to invoke it asynchronously and what is the difference. Because the difference between synchronous and asynchronous invocation is very important in Lambdas related to the results destination. Okay. And error handling. For error handling, so the only entity that is responsible for error handling for synchronous invocation is you. Okay, or your code, of course, you have to you have to handle it manually, okay, or like write some handlers that will catch some error, some exception thrown by your Lambda function, and then cover it. Okay, handle this. Pretty straightforward. It is you who is responsible for handling. Let's move forward. Now, asynchronous invocation. And the difference is the following. Instead of AWS Lambda function, AWS Lambda service does not invoke your Lambda function directly, yeah, as it was for synchronous invocation flow. You invoke AWS Lambda, then it stores into internal event queue, which is then pulled by event listener, that is some special entity, yeah, to which you do not have any access. Yeah, you do not know how it works, but you know that this thing invokes your Lambda function. Okay, and you see, where do we deliver the result? For asynchronous invocation, we do not wait for the result. And we deliver the result using a thing that is called like Lambda destination. A Lambda destination is a relatively new thing, not relatively, if I'm not mistaken, it was introduced like 6 or 7 years ago, a lot of time ago. Yeah, but before you had to write some custom logic within your Lambda function in the end of the execution, which would deliver the result to your destination where you would like to put this to. And I think that it's pretty straightforward and pretty clear that it is error prone. Okay, fine. And how it works? Asynchronous invocation, it is okay, so it is we continue this flow, asynchronous invocation flow, with this diagram. Okay. After our Lambda function finishes its execution, the next step is to deliver the result into Lambda destination. And then sometimes you might ignore this data, or of course, if you want to store somewhere, if you want to store the result somewhere, yeah, and you use Lambda destination, you wouldn't use Lambda destination if you, okay, so you're fine with losing the result. And sometimes it's also possible. After you deliver something to Lambda destination, yeah, you read this using some different services. And now let's take a look at Lambda destination. We will get through this in workshop part as well. Okay, some services that might be used as a Lambda destination. You might either to store your result into SQS queue. Okay, you might store it into SNS queue, S3 bucket, Lambda, and even bridge. Okay, so let's do this. Okay, let's go to SQS queue. We will have the following setup. We will create one SQS queue for on success events. Then we will create another SQS queue for on failure events, and we will create dead letter. Okay. So let's create this thing. It's gonna be like workshop on success. SQS queue. Let it be so. SQS orders. Okay. On success orders. Actually, visibility time. Okay, let it be 30 seconds. So configuration, default configuration is fine. Okay, let's disable encryption. We do not actually need this. And access. Okay, let it be only the queue owner. It means that by default you will be able to access the SQS queue from your Lambda function. Okay, good. Because Lambda function in this particular situation would inherit your, like the invoker permissions. Fine. Let's move forward. Okay, we do not need anything here. Let's create a queue. Okay, so we have created the first queue. Now let's create the second one, which we will use for failures. The first one we use for successful results, and the second one we will use for failures. Okay, let me create the second one. The only difference will be the name. Failure. Okay, we do not need to change any configurations, but let's disable the encryption. We do not need this for this case. Okay, but never disable the encryption for a production-like environment. Never do so. Okay. Okay, everything looks good. Everything looks good. The only difference is the name. Okay, we have created two queues, like on success, on failure. And why did they add this like postfixes on success and on failure? You will see it soon. Okay, let's go back to our Lambda function. Let's get here and let's click on add destination. Okay, and we're interested in the following stuff: source. either asynchronous invocation or event source mapping invocation. Actually, we will cover event source mapping invocation a little bit later. And one spoiler, event source mapping invocation are synchronous. Yeah, and it is the exclusion from the rule that I've just shared with you a little bit before. Okay, and condition on success and on failure, of course. If your Lambda function fails, like for example with an exception, then it will be delivered to on failure queue. For on success, so I think it's pretty straightforward. First, we choose on success, we choose SQSQ, we choose destination, and let it be workshop on success orders. Okay. That's it. That's it. It means that our result will, okay, permissions. Permissions will be created automatically, of course. Needed permissions. So let's create this thing. Let's create this thing. Okay, it was a little bit. Let's wait for a little bit. A little bit more. Okay, it was created. And now let's create the second one. The second one for on failure. Asynchronous invocation on failure, SQSQ. Yeah. And the ARN of this is a workshop on failure. Perfect. Nothing else. Permissions are created by default. Okay. Good. So now we have two destinations. And the thing is this. One very important thing is that for asynchronous processing, we have retries. Yeah. If we take a look at this scheme, yeah, a little bit above. Yeah. If event listener itself invokes your Lambda function synchronously, yes, but it is a synchronous communication for your Lambda function invoker. Yeah, but how usually we build a synchronous communication? Synchronous communication, it is the combination of two synchronous communication, yeah, between the invoker, some intermediate node, and between the intermediate node with the target. Okay. Synchronous communication is like two synchronous communications. Lambda function, okay, event listener invokes our Lambda function synchronously, and in case it fails, Lambda function fails, it will retry it some number of times, which is fully configurable. We need to open our Lambda function in configuration tab. We need to go to asynchronous invocation, yeah, and we will be able to specify the retry times. Let's put it 0 because usually it uses exponential backoff. And if when I want, so I would like to show you the on-fail scenario as well, and it will make us to wait for a long time because it tries the first one, then it waits for 15 seconds, okay, then it tries the second time, and it waits for 60 seconds. I don't really want to make you wait. Therefore, let's specify it like 0, okay? Good. So now our Lambda functions won't have retries for asynchronous invocation. Perfect, perfect. Let's move forward. So we have just configured the...
Just a small question. Yeah, you mostly covered it, but I will anyway read it. With async-sync lambdas, do we need any resilience options like retries, circuit breakers, and others? Also, what about load balancers?
Yeah, that's a good thing. That's a very good thing to talk about. So the first, about the retries. For synchronous, as I mentioned before, your handling for synchronous invocation is fully on you. And retries, it's like, it's a strategy for error handling. Okay, so for synchronous invocation, there is nothing to add related to error handling. For like a synchronous invocation, there are some you're not directly responsible for handling the errors, namely how they're usually handled for asynchronous invocations. The first thing, you either specify some retries, and when all the retries fails, instead of delivering the result of your invocation to on success destination, it will be delivered to on failure destination. And I'm going to specify this thing. And the rules related to circuit breaker, if you want to like integrate circuit breaker into your Lambda function, and if it fails with something, it might not be actually feasible, because if you want to integrate circuit breaker into your Lambda function, when it communicates with some third party, yeah, because actually it's a good thing to think about. I don't really want to make any like prejudgment for this solution because I haven't thought a lot about circuit breaker within the Lambda function, and it is the good thing to brainstorm first. I would like to think about this first and then to provide the final result, whether it's a good idea or not. But related to the circuit breakers for the invokers for Lambda function, I believe it's a good idea. For example, if your Lambda function has an issue with some third party, for example, it's not able to connect to third party. Okay, it's not able to connect to third party, it fails. You might not be able to stress your Lambda function to stress third party with this failing request, and you might want to implement the circuit breaker on the invoker side. And actually, I believe that it might be a good idea to implement. It depends. You see, a circuit breaker on the Lambda side. It's a good question. You see, because usually the code is disposable. Actually, your Lambda function is disposable, and if you fail to request your Lambda, for example, third party to which your Lambda function relies, it's better not to wait. Okay, because usually quite often you might want to integrate use circuit breaker with backoff retries, and Lambda functions should be designed to be quick, yeah, because for every single second that you wait you pay, which is not a good idea. Yeah, I think that the best thing it is, of course, implement circuit breaker for invoker. It means that invoker invokes the Lambda function. Lambda function is just the intermediate node between the invoker and the third party. Our Lambda function always hits the third party, and if it fails for some time, for like 3-5 times, our circuit breaker goes to open state. It means that it stops sending the request to Lambda function, and it will use the previous results. Okay, so we're not able to connect to third party, and thereof we're not going to stress our Lambda function. I believe that it is one of the strategies, and I would consider it as a good one. But for some cases, you might want to follow different strategies. Of course, it always depends on, and it is always about trade-offs. Could you please tell me, did I answer your question?
I think it sounds very fair. So, yep, thank you, Mikita. Also, we have a great discussion in the chat related to cold start, but let's park this part. We have some brilliant comments there, but let's park them till the end of the session. Mikita, please continue.
Sure, let's proceed. Okay, related to asynchronous invocation, you should add just invocation type event. Okay, for synchronous invocation, the value for this type is request response. Yeah, but by default you're not required to specify this thing. Yes, because by default it's request response. But for a synchronous invocation, you need to specify this parameter. Okay, event. It is for CLI invocation. Okay, let's move forward. You're handling. Okay, we get there. So either on failure destination or dead letter queue. But dead letter queue is this not really deprecated approach, but currently, as I know throughout my experience, mostly we use on failure destination. But dead letter queue is not discontinued; it's still fully working solution. And the only difference, because on failure destination supplies you with more information in comparison to dead letter queues. Because if you specify dead letter queue, which also configurable, if I'm mistaken, yeah, here dead letter queue in asynchronous invocation for configuration tab. If you specify some queue for your dead letter, if you specify some SQS queue here, yeah, you see, AWS Lambda will store the event itself, but for on failure destination, it will supply it with the meta information. You see, it is the thing. Okay, let's move forward. Okay, let's test it. You see, we have some other Lambda function, and it is the create order invalid event handler, which is extremely simple. We just throw an exception. But let's first begin with asynchronous invocation for happy case. Okay, we go to test, we specify our event, and we choose the asynchronous invocation. And what do we do next? Also, we will take a look at the entities that are stored here. We have only one crayon. Let's replace it with, for example, with pencil. So this will be able to distinguish the data. Okay, and let's invoke it asynchronously. Also, let's open the SQS. and we will be able to get through every single thing, okay? We make sure that we do not miss anything. It's very important. Okay, you see, we have, we're interested in two of them, workshop, okay? Only two of them. You see, message available, 0, 0. Let's execute the event. Okay, we tested, you see, it was saved, and we do not have any response here, yeah, unlike for synchronous invocation. And if we're lucky enough, okay, so we weren't lucky enough, it worked quite fast, okay? You see, when we look at the destination, workshop on success order now has new message available. Okay, it means if we try to read this data, just 1 second, let's read this data. Where's this? Pull from messages. Let's take a look. Yeah, you see, here is the request payload, item name, pencil, and the delivery address is Tiflis, Georgia. Okay, pretty straightforward. Here we have not only the request payload, but also the meta information. And now let's test the not a happy path scenario. We have some create order invalid event handler, yes, that I've just shown to you, which consists of only logic related to throwing an exception. Okay. Okay, so we have created this thing. Okay, we have updated our Lambda function, and now let's execute this. Let's execute this thing. Okay, you see, handler was updated. Let's go to test and let's invoke test. Was it this? Okay, you see, we invoked, it is succeeded, but we know that this Lambda function cannot succeed because it throws an exception immediately after it is invoked. Let's go to our queues. Let's refresh them, and we will see, because our workshop on failure orders contains a mistake. Yeah, and it contains an error, a message with an error. Let's pull it and see. You see, it is here. And the difference between on failure destination with dead letter queue for Lambda is that in dead letter queue, you will only have these data. Okay, you see everything. So this is the example, like the whole message is for on failure destination, and the selected part, it is the thing that will be put into dead letter queue. Okay, good. Feel free to ask any questions if you have any. Okay, and this is the thing, how you're able either to, of course, and when you delivered something for on failure at the synchronous invocation, you're able to do whatever you want with the messages that were stored on SQSQ, okay? You might perform to, for example, the first idea that came to my mind, you might read this message and you might re-execute, resend this event somewhere. Or, for example, try to find a mistake there, troubleshoot and understand what is wrong with this message and resend this when you were able to find the mistake within the DTO. Okay, pretty straightforward, I believe. Let's move forward. Okay, related to our next part. Okay, error handling. Quite straightforward. We've just discussed this. Now, Volodya, I believe that you said that we had some questions. We might discuss them before we move forward to the next part, which is related to triggers.
Okay. It was like, summarizing of cold start discussion. So Evgeny, let me find this comment. Kostin, put a great comment. And when the Lambda starts time discussed, every time he feels that Lambda is chosen as an appropriate tool to resolve some task problem issue. And then the team bravely starts to fix Lambda cold start instead of using another tool. I think it's very fair. And we have one more question, one more comment about that. Sometimes project could already start with Lambdas, and during the development, this tool could become not very good one to solving some particular case. So I think that both comments could close this discussion. It depends from solution, from tools, from development of the project. So taking it all together, you should make a decision, use Lambdas or not, and when to finally choose some other tool. I think so.
Yeah, always keep in mind that Lambda function, it's not a silver bullet. It has a lot of disadvantages. The idea is cool, okay? The idea is the following. You just focus on the code and you do not care about the underlying infrastructure. The idea is interesting, yeah? Yes, but in the reality, it's not always like this. In order to use a Lambda function efficiently, if you would like to avoid performance degradation or skyrocketed BO, you need to understand how it works under the hood. Because you see, there's a huge difference between like using static code optimization and not using this, especially for high load. Yeah, when it differs in like a lot of money, then you feel the pain. Okay, good.
And also it requires special approach to the architecture in general. Like on your slide, it should be event driven mostly. Yep. So take it all into account.
Yeah. Thanks, Vladimir, for the assistance. Okay. Do we have any other questions before we move forward?
No, let's move forward.
Perfect. Let's move forward. So now we're going to talk about very important, very interesting stuff. It is the real case scenarios for AWS Lambda. Usually, you never invoke your Lambda functions using the test button. You do this only during the development stage. Yeah. Usually, you integrate your Lambda function with some services such as S3, API Gateway, SNS, yes, stuff like this. And when, for example, your user invokes, so your end user invokes your like API Gateway, or someone stores something within the S3 bucket, it is the trigger. It is the trigger for your Lambda function. It invokes the AWS Lambda. AWS Lambda invokes either synchronously or asynchronously your Lambda function, and then the result is somehow delivered to you. Yeah, usually using the on success or on failed destinations. Okay, and of course, as I mentioned before, whether synchronously we might know. Okay, so the type of invocation, either synchronous or asynchronous, it depends on the service that you want to use. Okay, and let's take a look at this. We will take a look at this a little bit later. And very important thing to understand, event-driven trigger. Actually, you will never be able to see this entity, as at least I wasn't able to find this thing. But maybe you will be able to use some sophisticated CLI command and you will be able to fetch this information. Yes, but directly you won't be able to access this entity. What is this? Event-driven trigger. It is the thing that contains all the necessary information for your service, for example, S3 or API Gateway, related to invocation of your Lambda function. For example, Lambda function name is just a guess because it is impossible to know what is actually stored there because it's like a closed solution. Yes. What is the name? So, for example, the format of argument, stuff like this. Yeah. Event-driven trigger, they think about when and how to invoke your Lambda function. Yes, and this trigger is stored on like side of the service that wants to invoke your Lambda function. Usually, I do not really think that this information is useful, yeah, because I cannot came up with an idea how it works under the hood. But no, actually, I can. At least it is important to know whether invocation is synchronous or asynchronous. For example, API Gateway is synchronous. It means that you will use synchronous invocation against AWS Lambda function, which means that your Lambda function should deliver the result back. And if you expect Lambda function to deliver this data, this request or results to on success destination, you will never see it there. You will never see it there. Yeah, and it is important to understand this thing. You will see asynchronous. You will see events related to success in unsuccess destinations only for services that use asynchronous communication communication approach with your Lambda function. Namely, I'm talking about S3, SES, simple email service, and SNS, simple notification service. Okay, pretty straightforward. And let's try to do this. So how we're going to do this? We're going to create simple notification service. Yeah, let's create a topic. Workshop SNS trigger. Okay. So let it be FIFO, nothing else. We're okay with the default parameters. Let's create the topic. Okay, the topic was created. Okay, now the topic was created. Now we're getting back to our Lambda function. We're going to add the trigger.
we're going to specify the SNS, and we're going to check. Yeah, you see, I created the wrong type. I created the FIFO, and FIFO is not supported. And this is the good thing, because when I was testing, yes, I specified the standard one. Okay, let's specify the standard type. Let's specify the workshop SNS trigger. Okay, this one, nothing else. Let's create a topic. Good. Let's get back to our Lambda function. Let's refresh the values here. And yeah, we will be able to see our workshop SNS trigger. Yeah, that's a good discovery. It's impossible to use FIFO queues with... because yes, you see, because FIFO ensures, in terms of SNS, it ensures that all the events should be processed in order. And if you process it asynchronously, SNS works with AWS Lambda in a synchronous way. Yeah, you might end up in the situation when you process when first message in SNS is sent to Lambda function, then it stuck into the queue because of the retries. You're constantly trying to retry this message. Yes, you're trying to invoke your Lambda function against this message, and it constantly fails. And then there is another one that comes to this particular flow. So the second message from SNS, the FIFO, comes to the AWS Lambda. AWS Lambda saves it into the internal queue. Internal queue is fetched by Polar, and Polar invokes your Lambda function. And the second one might succeed. And you see, and in this particular situation, the order of processing is inverted. And probably this is the reason why FIFO is not supported. Yeah, it's just a guess. I've just found out it. Okay, good. So we have created this SNS topic. We create a trigger. It should appear it soon. And the thing is this. You see, now let's take a look at simple look at the Lambda function, which supports the SNS. The thing is this: for SNS sends us different DTO. You see, for create order event, the DTO was quite simple. You see, item deliver address. But for SNS, it's going to be much more complex. It uses its own DTO, which has a lot of fields, and it works like in a batch manner. And we are able to process all of them like at once. The thing is, this code here is not a good practice, because I process all of them sequentially, and I put. Vladimir, do you want to say something?
Yeah, I just want to say that it's like 3 minutes left. So Mikita, try to wrap it up.
Sorry. Okay, let's try to do so. The time flies. I didn't even notice this. Okay, let's edit. It's gonna be like this. Let's save, and let's go to our SNS. Yeah, let's publish some message. We will take the text of the message from here. Publish message. Let's specify, for example, keyboard. Keyboard. Okay, and okay, fine. We publish this message. We published it in SNS, and now it is going to be propagated to our AWS Lambda function. We will see on success event here, yeah, and we will see a new item in our DynamoDB. But let's wait; it should appear soon. Yeah, you see, we have new item in DynamoDB. Keyboard, Tiflis Georgia. Okay, everything is fine, and we should see new synchronous. By some reason, it has arrived. Yeah, and considering the DTO, let's take a quick look. You see, it is much more bigger than the initial one, and the body consists of these records. You see, there are a lot of them, a lot of information. I don't even know where it ends. Okay, good. So unfortunately, yeah, we're running out of time. I believe, yeah, unfortunately, we didn't manage to cover the last part, like event source mapping, but in a nutshell, it is the batch processing for AWS Lambda. Not a good one, but still batch processing. Yeah, which you use for queue-based and stream-based services such as SQS, Kinesis, MSK, MQ, and DynamoDB streams. Okay, time is over.
Yeah, thank you very much, Mikita. Guys, you are a great audience. Thank you very much for supporting us in the chat, especially Alexander Vankov. Thank you for providing your comments, and thank you everyone who was talking in the chat and asking questions. Also, guys, please encourage our dear Mikita by saying hello on their community platform. He was working hard on this presentation, and I hope that it helps you. Thank you very much. Mikita, last word from you.
That was good. Thanks, everyone. You were a good audience. Unfortunately, I don't know your name, guys, and unfortunately, I don't know how many of you watching this thing, but I believe that at least I believe that it was useful for someone. Yeah.
Thank you. Bye-bye, guys.
Bye to everyone.